Techmax is a technology company. We are a human-centric organization. We have been trusted by over 50 companies across 15 countries in Africa.
From startup to cybersecurity titan, this is the Techmax Africa story.
My name is Patrick Kiniti. I'm the Chief Executive Officer and founder at Techmax Solutions Limited. We have been in existence for the last 2 decades. Over this period of time, we've seen us grow and evolve to the company that we are today. Apart from that, we are very passionate about technology and we are a human-centric organization. In addition to this, we have been trusted by over 50 companies across 15 countries in Africa to deliver for them various IT solutions.
We believe in progress with purpose. Techmax takes you further with frictionless cloud migration where possibilities are boundless. AI's insights become your foresight, guiding you towards excellence without compromise. We enable smart cities, making them tech-ready and eco-friendly, so you can go green as you go further. Our commitment to sustainability means a greener, more sustainable tomorrow. Go cloud, go further with Techmax. In the digital realm, our cybersecurity solutions are your digital armor, just like a turtle's protective shell. We empower you to navigate the digital space with maximum confidence and security. At Techmax, we are not just rebranding, we are redefining the future of innovation and sustainability. Join us on this exciting journey.
Good morning, everyone. Good morning, ladies and gentlemen. My name is Ruben Balanya, and thank you very much for joining us on this webinar today, where we'll be delving into data contracts, what exactly they entail, and how they can help your enterprise further engage inside their operations and their day-to-day activities. So without further ado, let's begin. So first off, I'm going to share my screen. And as I'm sharing my screen, there is a poll in the chat. If you could kindly fill it out just for us to get a feel of how we could further assist you in your data and AI journey. Thank you very much. Right, so let's get into it. So this is the Techmax Data and AI webinar, where we'll be discussing data contracts and how to effectively build trust within your enterprise data. And we'll also be ensuring that we deliver reliable data inside these hybrid ecosystems, whether it be on the cloud, whether it be on your private cloud somewhere within your data centers, or on premises as well. We want to make sure that you understand how to efficiently move data across the pipeline to ensure that your data streams receive quality, fresh, timely, and consistent data across all their operations. So this is what we'll cover today, starting off with the crisis, why silent data failures cost millions and erode user trust. That is the data failures you wouldn't really expect to see, or the ones that don't appeal to a larger audience at a first glance. Next, we'll define the concept, that is defining the technical and the business scope of data contracts and what they mean for your organization, and the solution to ensuring that you have reliable ecosystems within your infrastructure. How schema registry would automate this enforcement. And after the presentation, there's a demo coming up of how you can use data contracts and schema validations to ensure that you receive reliable data within your pipeline. But first, a bit about us as an organization, that is Techmax Solutions Limited. So we've been in business for around 23 years now. We first started off as a computer hardware solutions enterprise. Our founders used to sell computer hardware such as mouses, keyboards, monitors to clients and customers in the CBD. That was B2C entrepreneurship. Judging from the increasing technological demand in the threat landscape, we quickly transitioned into an opportunity where we saw that we could help organizations further enhance their technicality by teaching them Linux tips and tricks. Remember, this was around the 2008, 2010 era where most of us today would have probably not even have heard of another operating system other than Microsoft. So our founders were at the forefront of introducing Linux into the marketplace, into the organizations, and they were at the forefront of teaching these concepts to the various stakeholders and shareholders within the technical sphere. Moving on from Linux, we transitioned into cybersecurity. This was as a result of numerous high-profile attacks on various organizations where we saw a gap to enter the market and provision both cybersecurity solutions, cybersecurity services, and consultations in order to help organizations prioritize and bolster their cybersecurity infrastructure to make sure that no malicious threat actors could dare try to infiltrate the organization. So that was around 2010. And now with the turn of the next decade, where we see a lot of potential for both generative AI as well as classific AI that classifies various data sets into categories, we found an opportunity to come into the market to get into the data and AI space. So as of currently now, we have two arms within our organization. We have the data and AI sphere, and we have the cybersecurity sphere. So my name is Ruben Balanya, and I've had the privilege of working in both areas within the organization. So I'm both a cybersecurity engineer and a data and AI engineer. But for today, I'll take on the role of the data and AI engineer as well as the technical lead. So in the picture that you see within the slide, the one in the white shirt is me, your presenter for today. And the one in the magnificent suit to the left is Francis Mburu. He is the data and AI lead, and he's the one that started the data and AI department. So we are the engineers for the AI era. We specialize in high-scale event streaming and enterprise governance. So we don't just sell the software, we architect the trust systems that power your modern decision-making. So we sit at the data engineering level mostly, and we aim to assist the data analysts and the data and AI developers to make sure that they are provisioning correct, accurate, and consistent data to the decision makers for better insights within the organization. Also an event streaming strategic partner. That is, we bring deep expertise in schema registry deployments and Apache Kafka architectures through our various partners, as you will see when I showcase one of the demos that we have. On to part one, the invisible crisis, when schemas change without warning. So as an example, we can look at the simple quote-unquote rename failure, where we see a producer update from version 1 to version 2. You'd find that the developers within your organization for one particular reason or another, want to change the name of a field, be it for business logic or just to make it more aesthetically beautiful or according to organizational policies. So you'd find a simple rename, like renaming the field cust ID to customer UUID, would change such, you'd be shocked at how much of a gap this would change within the pipeline. You'd find warehouse ingestions fail immediately. AI models receive null inputs silently, or even financial reports would show $0 in revenue. And you'd wonder what would happen, what's happening, why would such a simple issue cause such catastrophic errors? That's what we're here to find out today, and that's what I'm going to take you through. But keep in mind, things that you may or may not have thought about when you're changing fields within your application might cause several other applications within the organization to break. So just keep that in mind. We move on to the massive cost of chaos, where you'd find such a simple failure would lead to, shockingly enough, a $12.9 million average annual organizational loss. That's on average by the research done by Gartner and IBM. And as a real world example, a couple of years back, Target, the retail giant, wanted to expand its operations into Canada, and they wanted to do it at a very aggressive rate. But due to improper contracts and data rules in place, this led to a 2 billion loss on their end, simply because, as an example, you'd find in the infrastructure, they're using various applications such as enterprise resource planning. You'd find they'd have a SAP application. You'd find they'd have warehouse retail application and supplier and organizers applications where the suppliers would fill out the supplies and it would flow down into the warehouses. On the downstream, you'd also find you have consumer applications and consumer infrastructure, such as the stores that were to be issued the resources provisioned from the warehouse. So you'd find, let's say, as an example, a supplier is sloppy in the operations. They're just filling out data for the sake of filling it out. And the system, mind you, doesn't have any constraints in place. So the system takes the garbage data as it is and puts it into the pipeline. So you'd find a lot of miscellaneous, low quality data or inconsistent data flowing along the pipeline. But to give an example, let's say Target is sells items such as desks or chairs. If I'm a supplier and I'm sloppy and I put in the measurements for the desks and the chairs into the system, let's say I put in -1 for the height of the chair. We all know you can't have a chair that's negative in value. That's simply just impossible. And mind you, these are millions, billions, and trillions of data points at scale. It's not just one incident. I hope you can see how this would affect the supply chain to a horrendous state. Let's say, as an example, the warehouse application is taking in data, but it's not processing it correctly. So it's at a point where the data shows that there's no supply within the warehouse, but there is supply within the warehouse. So what does that mean for the retailers who take in the material from the warehouse? This means that they don't get the material in time. And as a result, the customers are the ones who bear the costs. In that, let's say I'm a random customer going into Target and I want to buy an office chair, but there's no stock. They're out of stock. There's nothing within the store. I come again and again and again, and I enter into the store. There's nothing. Over time, I'll just choose another supermarket. I won't even bother coming because all the time I'm seeing there's no stock or there's poor quality infrastructure within the store. What does that mean? It means it leads to a loss in organizational reputation, which in turn leads to losses, financial losses within the organization. And this is where Target drew its $2 billion Canadian dollar loss when it was trying to expand into Canada. So data contracts, all this to say data contracts aren't just something we're talking about in theory. These are actual things that you need to implement within your organization to ensure that data flows smoothly from producer application to consumer application. Sorry, I was just checking for any questions on the chat, and feel free to ask any questions about anything you may need clarification on during this session, or anything you might want to ask as well. So the research by Gartner and IBM shows that poor data quality isn't just a technical debt. It's a multi-million-dollar revenue leak, as shown by my example with Target chain. Schema volatility is the leading cause of data downtime in event-driven organizations. That is, organizations who have shifted the paradigm from traditional batch architectures to event-driven architectures. So over 53% of engineering capacity is wasted on troubleshooting broken pipelines instead of building new AI capabilities. That is, instead of driving the frontier and driving AI into making sound, correct, and amazing insights for your organization, your team is busy just fixing the leaks, fixing the downtimes, trying to put out the fires instead of being creative and being authentic. So you'll find the whole reason why we've implemented this thing in the first place is being wasted because we're too busy trying to fix the infrastructure that underlies the AI-powered growth that we want to achieve. We move on to the system crash versus the silent failure. So we have a pipeline breakage where everything just stops at once and alerts are fired quick steps as soon as the fault arrives. This is sort of quote unquote a good failure because at least you know the system is down and something needs to be fixed as soon as possible. Troubleshooting needs to happen. You know exactly when and where the change occurred because everything broke at once. So at least with this one, you can at least identify the issue quickly and try to troubleshoot it quickly. As opposed to a silent data decay, where yes, the pipeline is running, everything seems to be going according to how it's supposed to go, but you'd find that at the end of your pipeline, where at the end is actually where this whole data and AI thing, that's the reason why organizations are shifting, because we want to make better decisions. We want to have better insights. We want to have more beautiful reports that encompass everything within the organization and give us key insights. But with the silent failures, you'd find you're getting hallucinations, you're getting bad data, you're getting values that are null or malformed. Your LLMs, your generative AI, your machine language models continue to make decisions based on garbage data before anyone can even detect that there's an issue within the pipeline. So that's a massive cost within the pipeline caused by low quality data that hasn't been detected early enough, or even better, hasn't been rejected by the system. We move on to part 2. That is, now we're defining what the data contract is, the key reason why we're here, and how we can use it to further enhance our organizational pipelines. So the contracts are actually the blueprint for reliable data. So we're moving to a cultural shift whereby data is now being viewed as a product. That is, data needs to have contracts, it needs to have ownership, it needs to be governed, to be of the highest quality, and it needs to be encompassed into various organizational domains. So from our framework, that is the Techmax data governance framework, data is a product. And like any product, it needs an agreed upon contract between the builder and the user. That is as an example, these contracts that we usually have with the applications and us, the terms of service, the end user license agreements that all of us usually don't read but sign anyway. But yeah, data also needs contracts in order to enforce governance, security, quality, and lineage. You also need to know where your data is at all times, who owns it, who has access, and is it secure in case it's personal identifiable information such as names or health status. These are the pillars of a data contract. This is essentially what a data contract is. They consist of the following: structures and types. So you have the data structure, which is the actual definition of the data, its fields. As an example, a name field, an email field, an ID field, and their types. So a name could be a string or a varchar for those who use database lingo. A phone number, of course, would be an integer. And these structures are explicitly defined either via organizational policies or by developer protocols. And the languages used to define them include Avro, Protobuf, or JSON schema. So these are just how you define the data. And I'll show you an example of this during the demo session. So no more guessing field formats. When a producer, that is an application that wants to write into the backbone of the data streaming event, wants to produce data, it needs to know exactly what it is putting into the event pipeline. You can't have, as an example, a number being inputted into a name field or a name being inputted into a number field. Then we have the semantics and the quality. The business rules, as I was talking about earlier, as an example, price must always be positive. You can't have a negative price for something. And you also need to have regular expression patterns for personally identifiable information. That is sensitive data within your organization, like someone's name, someone's ID, someone's phone number. Like we've all seen the transition of M-Pesa right now, whereby if you send someone money, you can't see all the values within the number. So this helps curb malicious users out there, like these scam artists who usually call people to try and get them to pay rent, for example, or they try to come up with funny messages like, your daughter hasn't paid the school trip fee, for an example. Yeah, so we also need to ensure that we can mask our sensitive data, and this can be achieved by enforcing patterns for PII detection. Next, we have evolution rules, which are clear policies on how the schema can change, like is it backward compatible? Is it forward compatible? Is it compatible both ways? That is when developers of either producer applications or consumer applications want to change how fields inside the data process information. Let's say you want to add a new field inside the schema of a database or remove a field. This is where schema evolution occurs. And finally, we have the ownership metadata. Who owns the producer within the organization? Who are the downstream consumers? Who is on call in case of anything that happens? We need to know all of this to ensure proper governance, to ensure that your data is trusted, it is of high quality, it's consistent, it's reliable, and it's feeding the AI with proper semantics about the organization. Remember, this is your organizational data. It's not just anyone's data. So you need to make sure that you're handling it carefully and you're processing it in an organized manner. So the data contracts are the bridge to trust within an event-driven architecture. In a modern decoupled world, that is, we're moving from an age where applications used to be built, everything inside one package that is a monolithic application or monolithic applications, to microservices, APIs, and endpoints, whereby multiple applications communicate in order to achieve the same thing. So what we mean by decoupled is that, let's say I have to my left a producer application and to my right a consumer application. Decoupling means a scenario whereby my left application can produce data towards an event streaming backbone as much as it wants. It doesn't care who receives the data, what the data does, what other application does to the data. It just produces its data and it's done for the day. It's done its job. And the consumers can consume the data from the pipeline as often as required or as much as they want. That is, the consumer and the producer don't depend on each other in order for operations to work. Unlike in the past, where in monolithic applications, you'd require first the producer to finish, synchronize, and then the consumer to do its thing. Yeah, so this allows the producers and the consumers to move at different speeds and to do their thing as often as they want without relying on each other. The key word is that they don't rely on each other in order to do their work. So in this world, this modern decoupled world, the data contract acts as the stable output port, whereby producers can output to the event streaming platform, knowing that they've output the correct data, of quality data, consistent data, and data that is meaningful in the pipeline. So it acts as a stable output port for the producer and the input port for the consumer. That is, the consumer also knows that it can reliably consume the data that is in the pipeline without the data corrupting the consumer or making it to crash. So this allows for data mesh principles where domains own their data quality as a first-class product feature. That is, each and every domain of the organization has its own data product. The finance team has its own finance product. The HR team has its own HR product. The technical team has its own technical product. And all these products can be intermingled and intertwined as needed. Remember, we still have governance in place to ensure only the people that are authorized and authenticated have access to these valuable data products. Next, we move on to part 3. That is the implementation of these data contracts. And this enforcement is done via the schema registry, as we shall see. First off, the role of schema registry. Firstly, we have gatekeeping. That is rejecting any message that doesn't match the registered schema version. So this is basically a way to keep out garbage, low quality data from entering the pipeline in the first place. Remember, prevention is better than cure. If we can get to a state where we know for certain the producers are producing excellent data into the pipeline, we are satisfied. We are at least at ease with the fact that the data pipeline has reliable, consistent data flowing through it, and we can focus on other things such as building up the organization, making sure the AI is actually being used to implement forward thinking and forward changing ideas. Secondly, we have a central catalog. The schema registry acts as a central catalog to see every single data format across the enterprise that has been used or is being used or was used in previous iterations. In case of historical changes or in case anyone wants to take a look at how data was being processed before, to ensure that they can process all consumers or all producers in the appropriate manner. And we also have optimization, whereby we can reduce the message size by sending schema IDs instead of raw schema text every time we produce messages into the pipeline. That is, we save up on so much space by only applying a schema ID to the data being produced into the enterprise data platform. So these are the various compatibility modes that you could have. There are many more, but these are just a start. First, we have the backward compatibility mode, whereby new consumers that have been updated to the latest schema can still read old data that was made by producers using the previous schema. So the developer action here, that is the action to be done by the developers actually making the consumer application, is to update the consumer application in whatever language they're using, be it Python, C++, Go, but they have to update it to take in the data according to how the schema has been evolved within the organization. Then we have forward mode, whereby all consumers can read new data that is being published with the new evolved schema. And the developer action is to update the producer application that is producing this data. The consumers can be left as is because they can read the new data from the new producer. Then we have full compatibility mode, whereby both directions supported. So you can either update the producer application first or the consumer application first. The order doesn't matter. Maybe you have an internal meeting where teams delegate or agree to update which application first. And then we have none, whereby compatibility is not checked. That is, you don't have a data contract in place. And this is really risky because there's high risk of breakage within the pipeline. There's high risk of the silent failures that we're talking about, which can really mess with your pipeline, and it will for sure make things tricky and harder to use and more complex. So we have a schema evolution example where we move from the first version to the second version, as we'll see in the demo later on. For the first version, we have the initial contract or the initial schema, whereby we have a user ID, which is of type string. So we have a field called user ID, and it is of type string. It's a simple required field, and consumers are built to expect this specific ID format. So your user ID must have a string in place. It can't have a float, a double, a boolean. It must only have string in place. Then let's say we need to evolve the schema because our company is growing. We not only need to take user IDs, we also need to take emails. Our application also needs to take emails. So version 2 will have the safe add, where we have the email field, which is also of a type string. But this time we add a default value. So we have a default value of NA. That's the default value. So by adding this default value, we ensure all consumers don't crash when they see this new field. Remember, you could have a consumer which hasn't been updated to take in this new email field, and the producers are producing the email field. So rather than the consumer crashing, we have a scenario where if it doesn't have the email in place, the specific email in place, it will just have a default value of NA in literal. So this is the ROI of automated governance. You'd find that data contracts reduce the mean time to detect by over 80% through proactive enforcement. Remember, by the time it's even getting to a place where you need to troubleshoot for issues, at least you know there's been a significant effort put in place to block low quality data that's not beneficial to the organization. You'd find there's a scenario whereby you could have monitoring in place whereby if a certain threshold of garbage data is taken into the system alerts you and you're able to rectify it. So on the chart, we see that the incidents triage using manual methods takes a 15-hour average in order to triage what's exactly causing the issue. But with contracts in place, can take just an average of 2 hours, significantly reducing your MTTD and enabling you to better fix and fix at a better pace the issues that arise in your enterprise platform. So this is how we'd help your organization throughout this contract journey. First, we design your governance frameworks and contract templates in order to ensure that before you even get issues, we're preventing issues from arising in the first place by ensuring data of high quality, consistency, reliability that is well governed and that is secure is flowing within the platform, the enterprise streaming platform. We'd also assist you to implement these schema registries, these data contracts, these robust architectures to ensure that data is flowing smoothly from the data engineering side to the data analysis side and the machine learning and AI side as well as to the C-suite level, to the key decision makers. We'd help you architecture and implement all of that. We'd also train your teams to ensure that they know what is expected of them within the pipeline, to know for sure that this is the type of data that is expected, this is who owns the data, where the data is supposed to be kept, how secure the data should be, who should actually be able to access the data. We train your teams to look at the data as a product, both from a data and AI perspective and from a cybersecurity perspective, to ensure that you're not only efficiently handling your data, but you're also ensuring that it's secure. So are you ready for Trust First architecture? Be sure to contact either me or info@techmaxkenya.com. The emails will be put on the chat shortly. And there's also a free 1-hour architecture review for the first 3 attendees to inquire. So as I'm logging into the demo site, feel free to ask any questions. There'll also be a poll that will be put inside the chat shortly after to review the expectations, the policies, and whatever else you expected from this session. And yeah, just let me put up the demo session. But I hope you've had an entertaining experience so far. I hope you've been able to learn a lot. And I want to make sure that you get the concepts as clearly and as simple as possible. So feel free to ask anything. Okay, so right now I'm in the Confluent cloud platform. These are one of our many partners that help us ensure the paradigm shift from batch processing to event streaming architecture is achieved smoothly. So if I go to my environment, which is the Techmax environment, we see we have the Techmax environment, and I have one cluster in place. That is the cluster that actually takes in the data from producer application, stores it in a durable storage log, and provisions it to the consumer applications. So I have an order cluster running, which is just a cluster for taking in orders from a retail shop and producing it to a downstream application. If I click onto the orders cluster, we get an overview where I have a producer application, that is this connector, producing data towards the topic of orders topic, that is the specific topic by which orders received from the retail application flow into this topic, and consumer applications are able to take in the orders from this specific topic. If I go into this topic now, within your workflow, and then the rules would define the specific data constraints. Remember the integers can only be of a positive number, or price can only be of a positive number. So if I come to schema here and I click on evolve, this is where, as an organization, we sit down with the technical team, with other teams, and discuss whether we do or we don't want other fields to be included into this schema registry. As an example, let's say we sat down and we said that if I quickly go back to these messages, we sat down and we said, you know what, item ID is too vague. We also want an item name in order for us to quickly identify what specific type of package we are trying to deliver or offload to our clients or to the warehouses. So this is how we'd achieve the schema evolution, by adding a new field. But it depends also with the type of compatibility available. So for this demo, we'd use the backwards compatibility type. So if I add the item name here, I've added an item name and I've given it a type string, and I've just randomly given it a default of all producers, so that we know that messages that don't have an item name have been produced by the old producers within the system. But first of all, let's say I made a blunder and I didn't include the comma in this Avro schema, and I tried to click on validate schema. We could see that the following error message is displayed. That is a pass error, and it will give you a bunch of things to try out and figure out on ChatGPT. But as for our demo, I know it's the comma. Let's see, I didn't have the defaults here, and I tried to validate the schema. We still see the comma issue. If I remove the comma now, we can see the schema syntax and compatibility check failed. That is, this isn't backward compatible because there's no default value. So let's just try quickly fix that. Accidentally went back, but let's quickly put in the new field. Okay, so now I've put in the item name and the schema syntax and compatibility checks were passed. So now if I save the schema, we see that we have a new data contract version that has been created within the infrastructure. And now we see that this is the second version that is currently being used. So as a result of this, if we had, say, new producers and we put in the fields for the product name within the producers, we'd have a scenario where now item names are being produced into the infrastructure as well. But with the old messages, let's say the current producer that we have now, since we are literally not changing this producer and it's the same application code, it still produces without an item name. But if this now produces to the new consumers, the item name will have the default of the old consumers. That is to show that this older version of the consumer is still producing messages to the pipeline, and that would be valid because that's how our organization has decided to keep up with the changes. Yeah, so that was a brief demonstration of how data contracts work out there in the field, how you can implement them, how you can change the schema evolutions, and how data contracts would benefit your organization as a whole in ensuring that there's reliable data flowing within the pipeline that is governable, of high quality, consistent, and reliable. So I'll just leave it for anyone that has any question before we end the webinar. I'll give it 2-3 minutes for anyone who has any question. Meanwhile, thank you so much for sparing your time of the day to join me and join my organization as we try to further enhance this data and AI journey together. And also, I would like to give a shout out to Sandra Chebet Kiptum and her team for joining in the webinar. I'm sure they're doing amazing throughout the data analysis journey, and we'd be more than welcome to partner or more than open to partner on any endeavors together. So just to reiterate, we're here to build the data infrastructure to enable your organizations to grow and fly towards generating key insights using AI and entrepreneurial data. Thank you so much. I see we have 2 questions in the chat, but one has been answered. Thank you so much, Kevin, for the feedback. And we'd be more than open to help you further enhance your real-time data for credit at your institution. Okay, so we have another question in the chat from Geoffrey. Insightful presentation. Thanks, Ruben. I'll just read it out. Thank you, Geoffrey. Just a quick one. Given the direction AI is taking and the rise of models that comfortably work with more unstructured data and the brittle nature of structured data, how do you think this changes data architectures for software solutions? So for me, I think we'd have to have more of a hybrid solution and architecture, whereby unstructured data is stored in public clouds in S3 buckets, for example, in AWS, so that you're able to quickly retrieve this data from the public clouds and augment it with your structured data within the environment. Because for me, it doesn't really make a lot of sense to store them within blobs or trying to fit them within relational databases. So it's more of a matter of storing the unstructured data in public clouds and having the access to manipulate them whenever possible. I hope I've been able to answer your question, Geoffrey. Still waiting for any other questions as we wind down. From Samuel, yes, the recording will be available to those who would like a recording. You can just send out a request to info@techmax.africa.
I remember vividly my first interaction with a computer was when I had an uncle of mine visiting from the US. He came with a Toshiba Satellite Pro laptop, and during this time he allowed us to watch a wrestling match on the laptop. So the way he was operating the computer, I could see him installing different applications and navigating. That really sparked my first interest into tech and into computers, and I knew that I would want to pursue this journey later on in my career. The second instance was later on when my dad acquired a laptop. We managed to do our first connection to the internet. Then it was using modem technology, so you could pick up landline, the telephone cable, and connect it to your laptop, and then it would do a dial-up connection. So I remember vividly loading the Yahoo page then. That was the main channel of communication and for people to browse the internet. And I was also very fascinated that we would communicate with people across the globe using this device and technology. Way back in 2003, when I initially registered the company and set office, I remember then Kenya had just gotten a new government in place.
Mimi Mwai Kibaki.
Businesses were booming, and also adoption of technology was one of the key things that people were trying to achieve. During these early days of Techmax, the business environment was very vibrant. I remember clearly people were setting up cyber cafes. There was also new opportunities that were coming out. Way back then, technology was not yet advanced because we were still using floppy disks, dial-up connection. But there was a lot of push by the government then to try and enhance the technology within the